Hi, and welcome to this live podcast from Ignite Orlando 2019. Together with me, I got my blue screen brother opinion, Olav Tvedt.
Yeah, and it's strange. We're actually starting to talk English when we're in the US. So,
yeah. And our super special guest, our VIP, Mr. Hyper V, Ben Armstrong.
Hi, Alex. It's great to be here and talking to you about all the stuff we have going on in Windows and Hyper-V, and a lot of really exciting announcements coming out around Ignite this year.
Yeah, so just give us a brief introduction on who you are.
Yeah, so I'm Ben Armstrong. I'm Principal Program Manager on the Hyper-V team at Microsoft, but I have been working as a Program Manager on Hyper-V since before there was Hyper-V. In fact, I've been working on virtualization in the industry for over 20 years now, with over 17 of those being at Microsoft.
So you really know your stuff. And,
yeah, absolutely.
Yeah, and you even got a quite interesting hashtag on Twitter, and you got a very special email at Microsoft.
Yeah, I'm known as the blogger Virtual PC Guy. You can email me, virtualpcguy, all one word, at Microsoft.com, and it will get to me.
Yeah, it's a...
Do you have the XP mode at Microsoft?
I won't go through. I have, over the years, I've collected a number of interesting email aliases at Microsoft. I could probably spend 5 minutes just going through all the strange email aliases where it's like, yeah, if you email that email alias, it just ends up in my inbox.
Oh, that's interesting. Okay, so what's some of the cool new launches and features that you've been announced here at Ignite from your perspective?
So, speaking as the Hyper-V guy, it's a great time to be on the Hyper-V team at Microsoft because we have so much going on at Microsoft, and all of it is building on virtualization. So, like, this show has been amazing. You know, we've had new capabilities that we've announced in Azure, new Azure services. We've had a massive set of announcements around our hybrid cloud strategy, talking about how we're expanding the Azure Stack family, introducing Azure Arc that everyone's super excited about. But we've also had a number of announcements coming out about devices where we're using virtualization. And as we were discussing earlier, I am super excited about a number of the security announcements that we've been making, which are actually all, grounded in virtualization.
So we've heard some talk about the Spectre meltdown, and you're talking about virtualization actually securing your PC, not being a risk?
Absolutely.
Yes.
So to give some full background here, I mentioned that I've been working on virtualization forever. Microsoft actually originally had the vision that you could use virtualization and you could use a hypervisor to bring a whole new level of security to a platform way back in 2004. There's been an active discussion and something that we've been working towards. And it's been something that has actually kind of snuck out in some ways that people don't really know about. One of my favorite examples is that the Xbox 360 actually had a hypervisor on it that was used to protect the firmware against hackers. So it didn't run virtual machines, but it had a hypervisor, and the purpose of the hypervisor was it was a very thin hypervisor that we built that was highly trustworthy, that was read-only in a protected section of the Xbox 360. When the Xbox 360 booted up, the first thing that booted was a hypervisor, and it would actually go out and validate all the firmware and all the chipsets and make sure that while the Xbox 360 had been turned off, no one had got to the hardware and messed with things. And only once you got a full clean bill of health on all the firmware did we say, okay, now we're going to boot the operating system. But this has been something that we've had in mind and we've been working on for a long time.
So was that a kind of start for what you see now on how you use the virtualization to secure Windows 10? So
it's actually, and as I said, the start was before that because it's been a big area of focus. But we've been when we sat down and designed Hyper-V back in we started development on Hyper-V in 2005. Even though the first release of Hyper-V was for Windows Server and we were just looking at private cloud, the team very much had in mind that one day we want this to be an amazing security platform that we can bring a whole new level of security technology to the market on. Now, business priorities, we spent a while just being like, okay, we're going to focus on server virtualization, but we were very architecturally intentional in building a security platform.
Yeah, so it's not changed just to adapt, but it's been built with the total.
It was built that way from day one. And to nerd out for a moment, if there's anyone listening to the podcast who is a hardcore old school security person, to explain just how intentional this was. When we were designing the original release of Hyper-V, we actually followed the EAL security guidelines for documentation. So all the specs and documentation for the original release of Hyper-V met the EAL 5+ certification, which is a really stringent documentation process. And I actually happen to know this number off the top of my head because I was actually involved in a security audit of Hyper-V just a couple of weeks ago. Every time we do a release of Windows Server, we go through and we do common criteria analysis, we do a full security audit, and so on. We released Windows Server 2019 earlier this year, so we're currently working with all the different groups and so on. And as part of this, I was actually asked to collate every threat model that we had for Hyper-V, and we have over 70 individual threat models that go in and look at the different components and understand how they've been secured. So it's always been a foundational belief.
And we've already seen some of the virtualization features reach endpoints and clients. So we were talking about hardware and we were talking about Windows 10. You mentioned Windows Server, but
yep.
We use virtualization to protect your Windows 10.
Yeah, absolutely. So this was actually, it was a really fun moment for the Hyper-V team because we have, always had this vision of using the hypervisor for delivering ultimate security. And it has been something that's been in the back of our mind. It's been something that we've been slowly working towards. And with Windows 10, we've been really able to kind of like unleash our effort. And to give a bit of a background here, it was really fascinating. We at Microsoft, we released Windows 7, and Windows 7 was a huge popular release with all the enterprises. Then we worked on Windows 8 and Windows 8.1, where we had more of a consumer focus, and the enterprises didn't pick it up, and that was kind of expected. So as we were coming out of Windows 8.1, our executives actually went around and they did a listening tour with all of our enterprise customers and asked the question, okay, what do we have to do with Windows to make it so that the next release of Windows is something that you will be like, really wanting to deploy, that there will be no hesitation. And like we were expecting to hear things like, we hate the new start menu and, all this stuff like that. We did not hear any of that. The one message that we heard from our enterprise customers was, if you can make Windows demonstrably more secure, we will deploy it tomorrow. And that really became a big focus for Windows 10. And so that came back to, we have our security team inside Windows, but we also have the virtualization team and the kernel team. And we worked together and we started building these amazing technologies. We started with virtualization-based security, which is our platform for building a lot of these technologies on. Then we released Credential Guard and Device Guard, which are amazing technologies. I could spend like 20 minutes talking just about Credential Guard. We then have even stronger technologies built on top of that. Two of my favorite ones are that don't get enough love and attention are HyperGuard and Hypervisor Enforced Code Integrity. which we call HVCI for short. And these two are very interesting technologies together. So what HyperGuard does is, and so if we take a step back and understand the technology for a moment, when you have a hypervisor on your system, it is responsible for access to the core resources like the processor and the memory. And the way we built Hyper-V, because we always had the security vision in mind, is that the version of Windows that you think you're using on your computer is actually just the first virtual machine. All of its access to CPU and memory is still regulated by the hypervisor.
Would that be no matter if you have installed Hyper?
No, it's only once you've enabled Hyper-V.
Because then you're lifting the layers, right?
So the way HyperGuard works is when the Windows kernel comes up and it loads, it will see like, oh, I'm running on top of Hyper-V, and it will call down into the Hyper-V hypervisor and be like, hey, I've loaded a bunch of data and a bunch of structures and a bunch of code into memory, and no one should ever modify this. Like, I need it here so I can read it, but I'm not going to modify it, and if anyone tries to modify it, it's because they're trying to attack the Windows kernel. So Hyper-V, make this memory read-only to everyone. And we can do that. And so now if you even if you get malicious kernel mode code running inside your Windows environment, there are sections of the Windows kernel that it can't touch. So that's HyperGuard, which is amazing. Hypervisor enforced code integrity is we have, for a long time now, we've had the concept of code integrity in Windows. And code integrity is simply that you can configure Windows in a secure way where, actually to make this really understandable, have you ever, when you install an application on Windows and you get the elevation prompt, most of the time it tells you oh, this is an installer from this vendor, and some of the time it tells you this is an installer from who knows, unknown source. The difference between this is one of these was signed code with a trusted certificate, one of them was not. Now, using user mode code integrity, which we've had for a while in Windows, as an administrator, you can go in and you can say, hey, no one is allowed to run anything that doesn't have isn't signed. If it's unsigned code, we just don't run it. You can even go further and you can start to be and I don't trust these vendors, so I don't trust these certificates. However, that's only enforced for user mode code. It's not enforced for drivers. It's not enforced for kernel mode code. And that's where our hypervisor-based code integrity comes in, because we can bring the same level of protection to the kernel mode of Windows as well. And we can make it so that, one, you only load code that's signed, but two, every time that code gets loaded, we can actually check the checksums. We can make sure that it hasn't been tampered with. We can detect if it's tampered with at runtime, and we can dynamically shut it down. So it's an immense level of security.
That sounds like we really need to wrap up the hypervisor security platform. This is.
But it sounds also like you had Windows 8, a feature-driven operating system, but Windows 10 mainly focused to make everything safe and secure.
Absolutely. And I haven't even touched on things like Windows Defender Application Guard, which is an amazing technology for security, once again, built on top of virtualization.
Yeah, and we have done talks here, podcast, and I'm going to talk next week in Paris about Sandbox.
Yep.
Because the Windows Sandbox
is awesome.
It should be used much more by developer, tester, or ordinary user that's unsecure.
And it was, I talked about both Defender Application Guard and Sandbox in one of my sessions this week, and let me tell you, I stood up in front of a room full of people and I said, how many people here have used Windows Defender Application Guard? And it was not enough hands. It was 20% of the room. And then I said, how many of you have been browsing the web looking for a download and you found a link and you've gone like, I think that link's going to be kind of sketchy.
Yeah.
80% of the room. And then I say, how many of you clicked on it anyway? And once again, like 80% of the room. And I'm sitting there going like, people, like this is what Windows Defender Application Guard was designed for. And it's so easy because you just, once you have it enabled, awesome. So you have it there. You just open it, like you get to that moment, you're like, okay, Application Guard window, I have a new browser, and away you go.
So what is happening when you open something in Application Guard?
Black magic. It is. I would love to. I could go on for hours because it really is quite amazing technology. What we are doing is a number of things. The first thing is when you, at a super high level, when you start Windows Defender Application Guard, we are spinning up a brand new Windows 10 fully isolated virtual machine in a couple of seconds. And starting an instance of Edge in there and connecting you to it. Now, the fact that we do this in a couple of seconds in a really light way is where the black magic comes into play.
It's even faster than Sandbox in the store.
It is faster than Sandbox, and it is really quick to come up. And the interesting thing is, you don't have to install Windows. We don't have a second installation of Windows sitting around. What we're actually doing is we already have a copy of Windows that we trust. It's the one that's running in the host. But we create what we call a composed file system, where we're taking all the trusted files for the host, we compose them in a read-only way, expose them through to the virtual machine, boot it up, and we do all the file system tracking. We developed a new way to do memory management so that this is low impact on memory. It is really an amazing set of technology.
That's super cool. We've already seen web browsers being split away from Windows in a certain unnamed game console. Yep. So what's the story about that?
So what you're talking about is the Xbox One. Because the Xbox, and I mentioned at the beginning of this, everything that Microsoft is doing runs on top of Hyper-V, which makes it a really fun time to be me. The Xbox One uses Hyper-V. Ordinarily, the Xbox One is running between 1 to 3 virtual machines on top of Hyper-V. The first virtual machine is the one that's responsible for just the console experience, all the menus and so on. The second virtual machine runs whatever game you're playing right now, and then we have a third virtual machine specifically for if you want to do web browsing on the Xbox, and it follows exactly the same model as Windows Defender Application Guard in that you open up, Edge on Xbox, we spin up a virtual machine, you're in a sandbox, like you run, when you close it, we just throw that all away, just to have, the most protection here.
Are it going into a sleep state when you're...
No, we dispose it.
But I'm thinking about all the VMs, because if you have a game running and change it...
We don't dispose the gaming VM.
No.
Because we do a lot of publication validation and so on.
Yeah.
But for the internet one, because you could go to a random website and who knows what's there, whenever you close that, we throw it away.
Okay, yeah.
But one of the things that I'm really excited about, we actually announced this 2 weeks before Ignite, is the secured core PC.
Yeah.
And this is, starting a video there, this is a combination, this is the result of a number of efforts. So, as I mentioned, we have a number of security technologies that we've been working on. VBS, Device Guard, Credential Guard, Windows Defender Application Guard, Hypervisor Enforced Code Integrity. And one of the challenges that we have had is, I don't know if you've ever encountered this before, but often when you ratchet up the security, you break applications. and especially with a lot of these ones, with hypervisor-based code integrity, we could break drivers. And so at Microsoft, we've always had this vision and this goal that we've been working towards. And we're still working towards it, where we want to get to a world where we turn on all these security technologies by default. We don't want security to be an upsell feature. We want Windows to be the most secure platform for everyone, everywhere, full stop. Yeah. The challenge that we've had, though, is that we know that a lot of the security features will break popular applications or popular devices that are out there. And so for a long time, we've been in this mode where we ship the features, they're turned off by default. We tell everyone, you should really turn these on. Most people don't do it. Some of our very security conscious enterprises do it, but then they hit issues and they come to us and they say like, oh, like we got this device from this manufacturer, it's not working, we have to go and work, and on and on and on. So with Secure Core PC, there are really two key things to understand about Secure Core PC. The first one is that we've gone out and we've worked with a number of hardware OEMs to have them produce laptops and desktops. And yeah, if you scroll down, there's actually, at the bottom of this page, there's a list of ones that you can buy. Laptops and desktops that you can buy where, one, they ship with all of these technologies turned on, and two, the OEM has validated that everything works. So they make sure that all the drivers work, they make sure that everything works reliably, and so on. So that's the first thing we've done. And that in and of itself is a huge win. But the second thing is equally important. Now, anyone who's spent any time working in the world of security knows that what tends to happen is if you spend your time hardening one piece of the puzzle, then the bad guys just move to the next softest piece. And so we have been actively seeing that in the computer landscape. At Microsoft, we've been spending a lot of time hardening the Windows kernel. And so what are we seeing? The bad guys are starting to drop down a layer, and they're actually starting to go after the firmware. And we are seeing, in the wild, attacks against the firmware. And this is like worse, if you go back 5 years ago, the worst thing you could talk about from a security point of view was a rootkit. That was well, we now have worse. We have firmware attacks, and that's worse than a rootkit.
Yeah.
And so what we're enabling with Secure Core PC is we're enabling what we call a hardware root of trust. And what the hardware root of trust is that through using a number of various technologies, including TPM capabilities and certificates, and I don't have a half-hour conversation to explain this, we have worked with the hardware partners on a secured core PC so that when Windows first boots, and one of the first things we do in boot is we load the hypervisor, we can actually go and validate all the firmware on the system. This is exactly what we did in the Xbox 360. But we're now doing it for these general purpose laptops, where we can now, and it's through a close relationship with the OEMs, but we can now go through and we can make sure that those firmwares are absolutely clean. Now, if the firmware has been violated, we're going to crash Windows straight away and give you a lovely blue screen that basically tells you, you need to return this piece of hardware to your OEM and they need to throw it in a dumpster and you're going to need to buy a new one. Which isn't a great answer, but it is better than running on a compromised device.
Yeah. Is there any demo videos for that?
I do not know. I can ask around, but yeah, it brings a whole new level of security where when you have a secured core PC, basically by the time you get to the Windows login, we can guarantee to you that every firmware on that device is exactly the way the manufacturer designed it. We can guarantee that the Windows kernel has not been tampered with. We can guarantee that every driver that has been loaded is secure and signed and trustworthy, and that it all just comes out of the box.
So what made it so much easier to do that about 15 years ago in Xbox 360 than it is to a PC?
So the reason why, and I actually I was chatting to a member of the press about this earlier, because they were kind of scratching their head and saying it's a bit strange. Microsoft actually just before Secured Core PC came out, we actually enabled a bunch of our virtualization security technologies by default on our Windows on ARM devices, which we still haven't done generally on Windows on x86. And the real challenge with all of these is it all comes down to the size of the ecosystem. You know, with Xbox 360, one piece of hardware, and Microsoft has a lot of control over all of it, and a small set of apps that we're running. Yes, the Xbox 360 has a lot of games on it, nothing compared to the Windows ecosystem.
Yeah.
But when we look at the Windows ecosystem, you look at the huge breadth. We have so many different hardware vendors, so many different hardware devices. We have multiple different processors. We have different motherboard manufacturers. And we have more applications than any other platform in the world trying to work across that entire industry and be like, okay, now let's make it ultimately secure, is a Herculean undertaking. And what we're seeing with Secured Core PC really is the result of a decade of work, which is one of the reasons why I am so excited to see this coming to fruition.
Yeah, so how much have you been working with this on? You mentioned 10 years, but is this like...
It's a long time. So honestly, and like, not talking about Microsoft, which, like, something to understand about Microsoft is, like, everything that Microsoft brings out is almost always the result of a collaboration of multiple teams. You know, if I just look at Hyper-V, which is just one piece of this puzzle. One, we have been working on, as I mentioned, we always had this design in mind. We have been actively working on the technologies to enable this for 8 years now. And for the last, I'm going to just, rough estimate, I'm going to say for the last 4 years, we have had a team of engineers in Hyper-V where their lives has just been trying to get to a world where we can enable virtualization-based security by default.
So they just, for the first time in 4 years, they've seen the day of light.
Absolutely. Like, you should have seen how excited they were when we finally enabled VBS by default on the ARM platform. And the Secured Core PC, like, we're all like, yeah! But yeah, we've had a team where for the last 4 years, it's been like, okay, like, here are the hardware partners that we know we need to work with. We've been working with Intel, we've been working with AMD, we've been working with device partners and so on. And it's really been like a peeling the onion activity where it's like, we go like, okay, here are the set of things we know we need to address, and we go and address them, and then we get to the next step and we're like, like, we need to go and work with these people, and we need to go and work with these people. You know, one of the really fun ones that happened here is it was actually this goal that we have of enabling these virtualization technologies everywhere that led to one of the most unexpected events of my career in the last 10 years. And that was that this year I was on stage at VMworld.
Ooh. Yeah.
Because that was, I'm like, if you had told me that was going to happen like 2 years ago, I would have been like, no. But to give the story here, you know, we've been working on these security technologies. We've been talking to enterprises. Enterprises have been really excited about it. But one of the downsides has been that once people enabled these, they couldn't use VMware Workstation. And we have a lot of enterprises who use VMware Workstation. And so a couple of years ago, we reached out to VMware in one of the strangest hello conversations ever, and was like, hey, would you consider working with us to get VMware Workstation running on the Hyper-V hypervisor so that our shared customers can use all of our technology? And they said yes. And so for the last while now, we have actually very quietly had a team at Microsoft and a team at VMware working together to get VMware Workstation working on the Hyper-V hypervisor. This year at VMworld, they announced this effort. They flew me down to VMworld. It was definitely strange. I was like front row seat in the VMware Workstation roadmap, and you could have heard a pin drop when they're like, and now we're inviting Ben Armstrong from Microsoft to the stage. And I stood up there, talked about all of this, and then they demoed VMware Workstation running on a system that had virtualization-based security and credential guard and all of our technology enabled. So that was really exciting.
But that's what we need to make sure that security will be prioritized. Right?
Exactly. But this all comes back to, you know, at Microsoft, like our North Star here is we want Windows to be the most secure platform there is, unquestionably, and we want all of this technology turned on by default for all of our customers.
So security by design and by default.
Absolutely.
Probably some
cooperation.
Cooperation.
Yeah.
Yeah, least but not most. So.
But would the secure core PCs, would it be easy to see what model you should buy, or do you need to go into a list to figure out what you should buy, or will every new model sooner or later be a secure?
That is our dream.
Yeah.
Like we want to be in a world where we actually don't use the secured core PC phrase because it's just a PC, and that every PC you would buy would have all this on. We are not there yet. So here and now today, for enterprises, we are very much saying, like, go to our site for secured core PC, look at the list that we have there. When you're talking to your OEMs, when you're looking at hardware refresh, be saying, I want a secured core PC. Because that is how you're going to get all these technologies and know that you have this amazing security promise while still like having all the usability and functionality that you expect.
Oh, that sounds great. Yeah. So thank you so much for your time, Ben. It's been very, very entertaining, lecturing. It's been emotional.
Yeah. Thanks for everything you have done since.
I always love talking about our technology and what it enables people to do.
Yeah. So hope you enjoy the rest of what's last day of Microsoft Ignite.
Absolutely. I always love the last day because the people here today, they are the true fans.
Yeah. That's
the hardcore that stick to the bitter end.
Absolutely.
Right? All right. So take care.
Yeah. Thank you.